When determining the appropriate rating for a bus in a multimeter bank setup for an apartment building, it's crucial to accurately calculate the total load and ensure code compliance. In the situation presented, the initial meter bank loads, after applying demand factors from NEC Table 220.32, are as follows: meter bank 1 at 1069 amps, meter bank 2 at 1079 amps, and meter bank 3 at 857 amps. This results in a total calculated load of 3004 amps. Therefore, the bus must be rated to handle at least 3004 amps. If the bus is rated at 3000 amps and the three main breakers are rated at 1200 amps, 1200 amps, and 1000 amps respectively, the configuration is not code compliant. The combined amperage of the main breakers totaling 3400 amps exceeds the bus rating of 3000 amps. This discrepancy could create a hazardous situation. If all breakers were to trip simultaneously while approaching their full ratings, the bus would be overloaded, potentially leading to overheating, damage, or even a fire. To rectify this, either the bus rating needs to be increased to at least 3400 amps, or the breaker sizes need to be reduced so their combined rating does not exceed the bus rating. Regarding the application of demand factors, the NEC permits using Table 220.32 on the total combined load for the entire building before demand factors are applied to individual meter banks. Because a greater number of dwelling units are included in the calculation, this typically results in a lower overall demand factor. However, it's important to emphasize that irrespective of the demand factor applied, the bus and main breakers must be adequately sized to handle the total load after the demand factor has been applied. The process of calculating the appropriate busbar and breaker sizes involves several key steps. Firstly, determine the total connected load for each dwelling unit. This includes all lighting, receptacle outlets, appliances, and any other electrical equipment. Consult NEC Article 220 for detailed instructions on calculating these loads. Secondly, apply demand factors to the total connected load. Demand factors account for the fact that not all electrical equipment will be in use simultaneously. NEC Table 220.42 provides demand factors for general lighting and receptacle outlets in dwelling units. Larger appliances, such as electric ranges and dryers, have their own specific demand factors as outlined in NEC Tables 220.54 and 220.55. Thirdly, sum the loads for all dwelling units served by each meter bank. Apply the demand factors from NEC Table 220.32 to these subtotaled loads. This table provides demand factors based on the number of dwelling units served by each meter bank. It's critical to utilize the correct demand factors to avoid underestimating the actual load. Fourthly, calculate the total load for the entire building before applying any demand factors to individual meter banks. Then, apply the demand factors from NEC Table 220.32 to this total combined load. This method often results in a lower overall demand factor due to the larger number of dwelling units included in the calculation. Fifthly, compare the results obtained from both calculation methods, both the sum of individual meter bank loads after applying demand factors and the total building load after applying a single demand factor. The more conservative result, which yields the higher calculated load, must be used to size the busbar and main breakers. Sixthly, select the appropriate busbar size. The busbar must be rated to carry at least the calculated load. Consult manufacturer's specifications for busbar ampacity ratings, considering factors such as material, dimensions, and ventilation. It's advisable to choose a busbar with an ampacity rating slightly higher than the calculated load to provide a safety margin. Seventhly, select the main breakers. The sum of the main breaker ratings must not exceed the busbar rating. Individual breaker ratings should be selected based on the calculated load for each meter bank, ensuring that each breaker is sized to protect its respective load. Eighthly, verify the calculations and breaker selection with a qualified electrical engineer or inspector. They can review the calculations, verify code compliance, and ensure that the system is designed safely and effectively. Ignoring this step can lead to potentially hazardous situations. Ninthly, Install the busbar and breakers according to manufacturer's instructions and NEC requirements. Proper installation is critical for ensuring the safe and reliable operation of the electrical system. 10thly, conduct a thorough inspection and testing of the installed system. This includes verifying voltage and current levels, checking for proper grounding, and testing the operation of the breakers. Address any issues identified during the inspection and testing process before energizing the system. By following these steps and adhering to NEC requirements, one can ensure that the busbar and breakers are properly sized and installed, providing a safe and reliable electrical system for the apartment building. Improper sizing or installation can lead to overloading, overheating, equipment failure, and potentially dangerous electrical hazards. Moreover, documentation is important throughout the process. Keep detailed records of all load calculations, demand factors applied, busbar and breaker specifications, and inspection results. This documentation can be valuable for future reference, maintenance, and troubleshooting. When selecting a busbar, consider the material. Copper busbars typically have higher ampacity ratings than aluminum busbars for the same dimensions. However, aluminum busbars are lighter and less expensive. Choose a material that best suits the specific application requirements and budget. Also, ensure the busbar is properly supported and insulated. Use appropriate insulators and mounting hardware to prevent accidental contact with energized parts. The location of the busbar is also important. Install the busbar in a well-ventilated area to prevent overheating. Avoid locations where the busbar could be exposed to moisture, dust, or corrosive substances. During breaker selection, consider the interrupting rating. The interrupting rating of the breakers must be sufficient to handle the available fault current at the installation location. A breaker with an inadequate interrupting rating could fail to clear a fault, potentially leading to a dangerous arc flash or equipment damage. Coordinate the breaker trip curves with the downstream protective devices. This coordination ensures that the breaker closest to the fault trips first, minimizing the impact on the rest of the electrical system. Avoid nuisance tripping by selecting breakers with appropriate trip curves for the connected loads. Regular maintenance and inspection of the busbar and breakers are essential for ensuring continued safe and reliable operation. Inspect the busbar for signs of corrosion, overheating, or damage. Clean the busbar regularly to remove dust and debris. Test the breakers periodically to verify their proper operation. Replace any breakers that are damaged or malfunctioning. Address any issues promptly to prevent potential problems. When performing any maintenance or repair work on the busbar or breakers, always to energize the equipment first. Follow proper lockout-tagout procedures to prevent accidental re-energization. Use appropriate personal protective equipment, such as gloves and safety glasses, to protect yourself from electrical hazards. If you are not qualified to perform electrical work, hire a licensed electrician to do the job. Working with electricity can be dangerous, and it is important to take all necessary safety precautions. Furthermore, when applying demand factors from NEC Table 220.32, it is important to understand the limitations of these factors. Demand factors are based on statistical averages and may not accurately reflect the actual load in every situation. Consider the specific characteristics of the building and the occupants when applying demand factors. If the building has a high concentration of energy-intensive appliances, or if the occupants have unusual energy consumption patterns, it may be necessary to use more conservative demand factors or to perform a detailed load analysis. Be aware of any local codes or regulations that may impose additional requirements for electrical system design and installation. Local codes may be more stringent than the NEC in some areas. Consult with the local electrical inspector to ensure compliance with all applicable codes and regulations. Remember, the primary goal of electrical system design is to ensure the safety of people and property. Always prioritize safety over cost when making decisions about busbar and breaker sizing. A properly designed and installed electrical system will provide reliable power for years to come. An improperly designed or installed system can create safety hazards and lead to costly repairs. Therefore, it is essential to take the time to do the job right. The following summarizes key considerations. Firstly, the busbar must be rated to carry the total calculated load after applying demand factors. Secondly, the sum of the main breaker ratings must not exceed the busbar rating. Thirdly, the demand factors from NEC Table 220.32 can be applied to the total combined load for the entire building. Fourthly, the more conservative result from the two calculation methods must be used to size the busbar and main breakers. Fifthly, consult with a qualified electrical engineer or inspector to verify the calculations and breaker selection. Sixthly, install the busbar and breakers according to manufacturer's instructions and NEC requirements. Seventhly, conduct a thorough inspection and testing of the installed system. Eighthly, maintain detailed records of all load calculations, demand factors applied, busbar and breaker specifications, and inspection results. Ninthly, consider the material, support, insulation, and location of the busbar. Tenthly, select breakers with adequate interrupting ratings and properly coordinated trip curves. By keeping these considerations in mind, electrical system designers can ensure a safe and reliable power distribution system for apartment buildings.